This talk was given by a person from Manitoba. Her name was Nicole Armstrong, and she's in charge of an agency in Manitoba, and she was talking about Lake Winnipeg. Now obviously, where do you think Lake Winnipeg is? It's up in Manitoba. It's north of Winnipeg. Has anybody ever been to Lake Winnipeg? Is there anybody here that's been to Lake Winnipeg? You drove by it? Okay. All right, so Lake Winnipeg is up north. So what's that have to do with us? And the title of her talk was Collaborating Across Jurisdictions to Improve Water Quality. What's that refer to? What is a jurisdiction? What's that? It's a line, it's a boundary, right? What boundaries are we talking about here?
Between Canada and the United States?
Canada and the United States, yes. Because what we do here in North Dakota affects Lake Winnipeg, okay? And so she gave a little presentation. As I said, these were supplied by the Manitoba Department of Conservation and Water Stewardship. That was the department that this woman was in. And I must admit, this was written for a professional group, and I've taken out some of the more boring slides, but I'll try and explain it as we go through. But before we get into it, I just want to review some water quality basics. Very first, simple question that you always need to keep in the back of your head. It's so simple, but a lot of people never think about it. Question, why does a river flow? What makes water flow? Why are there rivers? Why are there streams? There's a very simple answer, but if you don't know it, when I say it, it'll be, oh yeah, that's easy. But can anybody tell me what it is?
Elevation?
Okay, elevation, and somebody said gravity. Same thing. Okay? Basically, water flows from high to low. What that tells you? Here in Valley City, we are higher in elevation than West Fargo. How do I know that? The Cheyenne River flows through Valley City, goes through Lisbon, Kindred, and then West Fargo. So, Valley City is higher than Lisbon, Lisbon is higher than Kindred, Kindred is higher than West Fargo. Where's the Cheyenne go then? It goes into the Red River, right? Where does the Red River go? Goes north to Grand Forks. So which is higher? Fargo or Grand Forks? Fargo has a higher elevation. What does it tell you about the city of Winnipeg? What's their elevation compared to Grand Forks? It's lower. It's all about elevation. If a river goes from point A to point B, point A is higher than point B. Like I said, it's a real simple concept, isn't it? But most people don't think of it that way. So, water flows downhill. The other point of this is upstream affects downstream. Everybody gets irritated about what people upstream are doing, but they often don't consider what they're doing to people downstream. A huge issue of this right now in the Fargo area is the talk about the diversion. The whole huge Fargo diversion. There is so much acrimony because people in different areas would be affected in different ways, and so it gets controversial. So upstream affects downstream. Keep that in mind. And then another thing to mention, a problem we're having, and this is what the PowerPoint is going to be about. It's going to be algae blooms. And what causes them? Nutrients. And nutrients, the main two are phosphates and nitrates. Where do you think most of those nutrients come from in North Dakota?
Farms.
What?
I said farms.
Yeah, agriculture. Okay, we're an agricultural state. So yeah, phosphate, nitrates, fertilizers get spread on the field, and they run into the rivers and streams. Okay? And the two main ones are phosphorus and nitrogen, and they lead to eutrophication. You know what the word eutrophication means? You have all, if you live in North Dakota, you should know what eutrophication means. Any reservoir you go to, any lake you go to, doesn't it get slimy green in the midsummer to late summer? That is eutrophication. Eutrophication is there's too many nutrients, and so you have all this algae growing, okay? And the other thing to keep in mind, we're going to focus on the Red River because that's what goes to Lake Winnipeg, and the Red River flows north. I am going to dispel a myth. Maybe you have, maybe you haven't heard this myth. There's some people say that the Red River is the only major river that flows north. That's not true. Rivers flow north, they flow south, they flow all directions. There's nothing special about the Red River going north. It just tells you that the elevation is higher in the southern basin and lower in the northern basin. That's why it flows north. Okay? So, let's talk about the problem, algae blooms. Algae blooms, all that green slimy stuff, reduced recreational appeal, economic social impacts, degraded aquatic habitat, low dissolved oxygen, they can clog fishing nets, drinking water problems, and where you hear about it, and you hear about this in North Dakota, in the late summers when we get a lot of algae blooms, you'll hear about somebody, and it's usually a dog or a pet, that got into a lake with blue-green algae, and they got a toxin and they died. There are blue-green algae that produce toxins. They usually don't affect people because people stay away from it because it's gross. But like if you've got a retriever or some other dog that loves to go in the water, do not let them go in the water if there's an algae bloom. They produce toxins. Okay? Why excess nutrients? Increase in nitrogen and phosphorus. And there's been a gradual but steady increase of nitrogen and phosphorus pollution in lakes and rivers over the past several decades, and this is a problem really for most of North America. It's not an isolated problem. Now I'm talking about lake, I'm going to focus on Lake Winnipeg now. If you've never seen Lake Winnipeg, it's a very large lake. It's located north of Winnipeg. Normally they have beautiful white sand beaches. Take a look at this beach. That's all algae bloom. And think of how pretty this beach would be if that wasn't there. Okay? So the nutrients and everything on Lake Winnipeg have started to become a problem. So, let's say you're in charge of Lake Winnipeg. You want to clean it up. Well, guess what? Not much. There's not much you can do at Lake Winnipeg. What are you going to have to do? You're going to have to try and work with people who are downstream of Lake Winnipeg. So, across the International Red River watershed, downstream in Lake Winnipeg, it's deteriorated. And it's not just Lake Winnipeg. All rivers and lakes across the Red River watershed are seeing it. Here's one from the Buffalo River, Sand Lake, Minnesota, Homing Dam in North Dakota, Pelican Lake in the Pembina River watershed. So we're seeing these algae blooms kind of all across the area. Now here's the Lake Winnipeg drainage. And it's really very big. So here's North Dakota. And you can see there's several different things that contribute to it. And so all these are coming in. So there's actually three main tributaries. The Red, the Winnipeg, and ooh, I forget the name of this river. This big river up here. Those are the main three coming into Lake Winnipeg. So, if you're in charge of Lake Winnipeg, you want to look at this, you want to look at this, and you want to look at that. By the way, is anybody here that's really knows their watersheds? They have a rather major mistake on this map. They call this the Assiniboine River, coming down in North Dakota. Is that the Assiniboine River?
Isn't that the Mouse River?
Yeah, that's the Souris, or the Mouse. The Assiniboine actually comes through here and meets up with the Souris, and then it's still called the Assiniboine. So that's actually the Souris River there. But you get the point that the drainage area going into Lake Winnipeg is very large. Now, after Lake Winnipeg, what happens to the water? Does it just stop there? No, it has a drainage into Hudson Bay. You see this little thing? There's a drainage here that takes it into the Hudson Bay. So the Red River and any river in the Red River Basin eventually goes to Hudson Bay. Here's kind of a close-up of the Red River Basin, just the Red River Basin. You can see all the rivers. Here's Minnesota, here's North Dakota, here's Manitoba. And so when they talk about cross-jurisdictional, we got to look at rivers over here, we have to look at rivers over here, and up here. And technically, you could also include South Dakota, because the Red River, the Bois de Sioux, which is the beginning of the Red River, actually goes into South Dakota. But these are all major contributaries. I was going to have you do a little activity right now, but we're behind on time, so I think I'm going to skip it. But basically what I was going to do is I was going to hand out maps of the basin and have you take where you're at and just trace the water. So let's say you're from Mayport, you're working on the Goose River, so you're working here, and this enters in the red, goes up here, and look at all these other rivers. And I was going to count up the other rivers before it gets to Lake Winnipeg. There's something like 23 more rivers that come in between there. If you're at West Fargo, you're right here on the Cheyenne River, which then meets up with the Maple, goes into the red, and it's going from here. And since we do have one group that's not in the Red River Basin, which school isn't in the Red River Basin? Yes, Montpelier. So I was going to have you look at the James River Basin. This is the James River, is a contributory to the Mississippi. So here's the James River up here. It comes down. You guys, Montpelier, somewhere in there. Joins up with the Missouri way down in southern South Dakota, which then joins the Mississippi. And so that drains down into the Gulf of Mexico. Well, anyway, let's get back to Lake Winnipeg. Let's look at what's been going on in Lake Winnipeg. So back in the 18 to 1900s, Lake Winnipeg would have been just a wonderful lake to live on if you could survive the winters. Back in 18 to 1900, that was a problem. Okay? It was what we call mesotrophic. That means there's good nutrients, but it's not so bad that you have algae blooms. The phosphorus concentrations were about 0.15 to 0.02. 0.02 is kind of considered the maximum before you get to be eutrophic. And then about 1900 to about 1990, all of a sudden those levels went up to about 0.5. And this is causing eutrophication. You're starting to get this algae and these algae blooms. They increased 300 to 500%. Phosphorus levels went up to 0.05. And then from 1990 to 2013, it doubled again. And so things are getting worse, and they're getting worse fast. Okay? So the current phosphorus concentrations are 0.1. And so the question is, how bad is it going to get? The more and more phosphorus you put in there, the more likely you are to get that toxic cyanobacteria. The more eutrophic it becomes. And so you have what was once a very beautiful clear lake that is very much becoming eutrophic. Okay. So what's the solution? Well, if you're from Manitoba, you realize you need help. Manitoba can't do much about it. They need people in North Dakota and Minnesota to try and come up with ways to decrease nutrients in their rivers and streams. Okay? So that's what the Red River Basin Commission has set up, one of the things the Red River Basin is supposed to help with. So there is some collaborative work trying to meet goals of nutrient loading, mechanisms for collaboration. And here's just a list of all the people, and I guess I should say, all the agencies that are being involved in this effort. You have United States, you have Canadian, then you have state, and provincial agencies that are all trying to work together to at least talk about the problem. So one of the things they've done is they're starting to come up with a strategy, and they call it the nutrient management strategy. And so the idea is to have a collaborative science and watershed-based approach to manage nutrients in the Red River and its watershed. Okay? So the Cheyenne and the Goose River, they're all part of the watershed. And hopefully it will prevent or help protect aquatic ecosystem health. And so here's kind of some ideas they have. Develop nutrient targets. In other words, how much phosphorus do we want to come into Lake Winnipeg? So the idea is, let's set a limit and we'll see what we can do to try and get the nutrients to reach that limit. So Lake Winnipeg and the area around Lake Winnipeg, the direct area around that, obviously Manitoba has to manage that. But the Red River and the Red River Basin, that's where you have to be cross-jurisdictional. You need to get help. And that's what they're asking from North Dakota and Minnesota, is for help. And so they started this program, and two things they noticed. First of all, they know there's algae blooms, and they know there's a lot of algae in the Red River system, but they really don't know what kind. There isn't a whole lot of data on what kind of algae is out there. And so somebody said, you know, at some point we should figure out what kind of algae this is, and maybe that would be helpful. And then they need to understand how algae in the Red River responds to nutrients. So in other words, you have to figure out the nutrients, and you should really figure out the algae. So one thing they did, this is a long, don't even try and read this. What they did is they came up with a plan to look at these two things, and like they say, it's an example of cooperation, because Manitoba, North Dakota, Minnesota, and the US and the Canadian government, they all kind of shared costs, staff, protocols, and they worked together. One of the things they did is they did an algae sampling. They picked out 30 sites on the Red River, and this is just this last summer, 2015. And they had all kinds of groups going out all the way from Lake Winnipeg. Here's Lake Winnipeg. Here's the city of Winnipeg right about here. And then once, of course, here we're in North Dakota. And they took algae samples the entire length of the river. This is kind of what they do, is they put in these slides, and they just put this in the water until the algae grows on it, and then they're sending it into a lab to have somebody identify. So they did this all along the Red. They also collected samples for phytoplankton, chemistry, and macroinvertebrates. And one thing they noticed is, boy, that algae really grew very quickly. When they put out those slides, the algae just kind of took off, grew very quickly. And so they hope to use this information for the nutrient targets. So then once again, going back to this, the nutrient targets. How much nutrients can go into, or would they like seeing going into Winnipeg? So what they just said, oh, here's the three rivers. So you have the Red River, you have the Winnipeg River, and it's the Saskatchewan River. Those are the three major rivers coming in, okay? And what they did some modeling, and they developed nutrient targets. So a target is how much you want to come into the river. And to kind of get an idea, let's look at where those are coming from. This is where most of the phosphorus for Lake Winnipeg is coming from. Where's most of the phosphorus coming from? The Red River. Look at the Red River compared, you're saying, well, why are they so worried about the Red River? Why not the Winnipeg River? Why not the Saskatchewan River? Really, the Red River is where most of the phosphorus for Lake Winnipeg is coming from. In nitrates or nitrogen, it's not quite as drastic, but it's still, the Red River is the largest source of nitrates going into Lake Winnipeg. Okay? What they would like to do, their target they have set is 2,800 metric tons of phosphorus per year. And what this is a graph going back to 1971. And you can see, let's take a 20-year period from here, 81 to 91. It only exceeded that level 4 times in 20 years. And the times it exceeded, it really didn't exceed by that much. Let's look at the last 10 years. 2003, at least they're on here. From here to here. We've got 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 10 years it has exceeded, and it is exceeded by very, very large amounts. So what they're saying their goal is to get that water coming out of the Red River to try and stay below this limit. Okay? And this is where they would take that measurement. Selkirk is a little town right before Lake Winnipeg. So this is their goal, 2,800. But, and really to tell you the truth, this is where it ends. What are some problems? This is where they're at. They're asking for help. What's the solution? Yes?
When you showed us that graph, the low ones corresponded with flood years. Like the flood in 97 was one of the lowest ones for like phosphorus going into the Lake River.
Good eyes. Why do you think that is?
Because it was able to soak through the ground and filter out.
What's that?
Like the phosphorus and nitrates were able to soak through the soil and filter out.
Possibly.
Or for
See, the other thing to think about, flooding occurs in the spring.
Yeah.
And have fertilizers been put on the field yet?
No.
No. And, of course, I don't know. You got a good point. I think there's a relation there, and I'm trying to figure out the explanation why, and I'm not quite sure. That's a good point.
I read somewhere in one of our sources, the kids use a lot of external sources for their research projects, and one of them was saying that it's a myth that nitrates and phosphates are lower in flood years, that they are higher because the floodwaters cover more urban landscapes and take all kinds of stuff off of yards and things that they don't normally take, so they pick up more, even though there's more water, they have more safety laws.
Yeah. Well, see, that's where this, yeah, I can see if you're a milligram per liter measurement, that would concentration make a difference, but this is tons. This is a different measure, so, yeah, that's a good question. I don't have an answer for you, but I like that, good eyeballs. But getting back to this, so the challenge now is what do we do? Okay? And to tell you the truth, when I'm at this conference, I can tell nobody has the answer. I didn't expect anybody to have an answer. Because really, if we're going to solve this problem, what would we have to do? Well, more research, what? And experiments. But when it comes down to it, where's it coming from?
Yeah.
Most of it's agriculture.
I have a solution.
What is it?
The government's gonna have to pay the farmers to plant buffer zones along the whole way, and it's gonna cost way too much money, and it'll never happen.
Exactly,
That's solution.
exactly. What you need to do is control farm runoff. How is that gonna go over in North Dakota? It's not. It's not. It's the reality of it. Minnesota, I don't know if you're familiar, Minnesota, this past year, the governor proposed doing what you just said. They were gonna do every riparian area for every little drainage ditch, everything. They proposed that there would have to be a riparian. What a riparian buffer is plants. It's like natural vegetation. The idea is when you get runoff from the field, it gets into that vegetation, and that vegetation pulls up much of the nitrates, and the phosphates, so they don't get into the water. And would that solve the problem? I don't know. It would help. It would be a big help. But even getting something like that passed, I would say it's not going to happen in North Dakota. So anyway, it's a problem. We are contributing to it. Agriculture in North Dakota is part of this problem. So it's seen an increase in algae blooms and eutrophication. The problem is multi-jurisdictional. They need the cooperation of North Dakota and Minnesota. And like I said, it hasn't been solved. I'm not giving you an end to this scenario. I'm just telling you what's going on right now. It will be able to be interesting to see in the next 20 years what happens to Lake Winnipeg. So I've got a few discussion questions. We already kind of talked, what are some of the possible solutions? Because let's put it this way. If you're going to come up with a solution, you're going to have regulations, okay? And regulations is a very dirty word to many people. The reason we have regulations is to try and solve problems like this. But companies, people, and especially farmers do not like to be regulated. So what's important? The farmers' rights or water quality for an entire area. You know, it's not easy. These are not easy problems. There's not easy answers. There's not easy solutions. And the thing is, it's getting worse quickly. You saw how it went from 1990 to 2000, no, 1990 to 2000 and whatever, and then the last 10 years it's doubled again. So it's one of those things that it's getting worse and worse. Now, is the current work on Lake Winnipeg, is it reactive or proactive? What do those words mean?
Before or after.
Okay? Explain.
Reactive is when something happens and you try and fix it. Proactive is trying to prevent it happening in the first place.
Right. Reactive is, okay, you got a problem, now let's try and fix it. Proactive, well, let's stop this problem from happening. What's going on here?
Reactive.
It's reactive. Okay?
Is Lake Winnipeg doing anything to stop it from going into Hudson Bay?
No, not really. And, well, I should say this, I'm not familiar with that end of it, because like I said, I got this at a Red River Basin Commission, and so they were kind of focusing on the Red River Basin. Nobody talked about what happens after Lake Winnipeg. But that, once again, that's a good question. I don't know. I think Lake Winnipeg acts as kind of a sink where most of them stay there, the nutrients, but I'm not sure. I don't know how big the problem is on the other end. Once again, very good question. So what way do you think is better? Should we be reactive or proactive?
Well, first you need to know if there is a problem, what the problem is. Or is there going to be a problem? I mean, is it foreseeable that there is something going to happen? Or...
You know, theoretically, proactive is better, right?
Right.
But,
Yeah.
yeah,
1/3 of the leaves are.
because it's very hard to be reactive because everything is set in place And you're going and you're asking people to change what they've been doing for decades. And that is very difficult. And you're probably not going to get very far. In fact, I'm going to tell you this quick little story. At this same talk, they had the lady from Manitoba talk, and then North Dakota talk, and Minnesota talk, and they talked about what they were doing to address this. In the North Dakota presentation, they made sure to state that they are not going to ask farmers to reduce fertilizer levels. They literally said that in their presentation. And when you say that, do you think we're really going to get anywhere? So, like I said, to me, it's an interesting example. Which approach is more difficult? I think the proactive is more difficult. Because first of all, you've got to see into the future that something might become a problem. And then you've got to convince people, okay, let's do this so it doesn't become a problem. And that's difficult to do. And so, in water quality, you know, like I'm saying, the big picture. We have you out working on your little streams, and I hope it's interesting to you, and I hope you kind of think about your little area, but keep in mind, it's all there's a big picture, and everybody is downstream of somebody, and what anybody does upstream of you is going to affect you, and what you do is going to affect people downstream of you. Any questions?
What kind of levels are we talking about for phosphates? That, like when we go out and test, we could say, oh, wow, that's gotta be agriculture. Let's say we're in the agricultural region and there's no other factors run, that would be obvious. What would be your level that you might say probably farm?
When they say above 0.2 milligrams per liter, that leads to eutrophication. Now, what was the natural level in North Dakota waters? I don't know. Maybe the natural levels were higher than that. It's hard to say. I haven't seen any data on that. It's very hard to say that, because that's another thing. This type, have you guys heard of point source and non-point source solution? Point source, you can say, that's where it's coming from. Let's do something about it. Non-point solution, point source solution is coming from all over. And it's very hard to regulate, it's hard to measure what is natural, what's coming off the farm fields. It's really, you know, and that's part of the thing where a farmer has a very good argument. How can you prove it that it's my fertilizer that's causing that? And I don't know.
Is there any correlation between the increase in the phosphate levels and the loss of the wetlands that like the government pays the farmers to keep?
Yes, because the wetlands tend to soak up the nutrients. They do a good job of taking out phosphate, nitrate. That's why the cattails grow so well and everything else. Yeah, wetlands do a very good job. Another thing that's happening in North Dakota, tile drainage. That is putting nutrients into the water very quickly. It's taking nutrients right off the field, boom, right into the water. Things don't look good for water quality in the future. I mean, it's something you're going to hear about. Our water is not going to get better at the current rate we're going. There's a lot of things affecting it, and there are agencies trying to deal with it, but they have a lot of problems trying to deal with it. Any other questions?
You said Minnesota, they proposed planting all those riparian zones?
Yep.
How, I mean, is that still just proposed, or how are they going to go about that, and why can't we do it?
I think the governor put it out there, and farm groups had a fit, conservation groups said it's great, and I think they've agreed. I think he took it back, and now they're talking about it, that maybe they can work it in, maybe not everything at once, but maybe they'll say water, anything a little bit bigger than this has to have a riparian zone. To me, it's a good start. I think riparian zone, adding riparian zone to our waterways, not letting somebody farm right up to the bank. So we'll have them leave 50 feet, 75 feet. Yes, that's a little bit loss in production, but it's probably gonna help that river quite a bit. And-
lose their loss of their land into the river anyway.
The erosion.
And
Yeah, good riparian zones help reduce erosion. Yeah, to me, the riparian buffers, that should be one we should be able to get people at least consider. I don't think it's that drastic. You're not asking the farmer, yeah, they'll lose a little bit of land, but hopefully it won't really impact them too much. I don't know.
Is that even being considered here, or, is that even being considered here, or, I mean, is anyone,
I don't think anybody's proposed it. I know there are people in the government agencies are waiting to see what's happening, because I know people in the North Dakota agencies, and they're waiting to see what happens in Minnesota. They're kind of watching Minnesota, and maybe if Minnesota comes up with something, maybe we could follow, I don't know.